This is our CS2316 final project, so welcome to our exploration of the shifting landscape of food prices over the last 3 decades. This project, analyzing the increase in grocery prices, healthy versus non-healthy food in urban areas, aims to uncover critical insights into how fluctuating grocery prices impact consumer behaviors, particularly in urban settings. The study's core interest lies in understanding the dynamics between the rising cost of food and the choice between healthy and non-healthy food options. So, by examining regional disparities in price changes and comparing the cost trends of nutritious foods, such as fruits and vegetables, against non-nutritious ones like processed foods, the project seeks to shed light on a crucial aspect of urban living. This analysis is particularly timely and significant given the increasing focus on health and wellness and the economic challenges many consumers face. For our data collection process, first we found a data set. So in order to do this, we searched for data sets online, we entered government sites, institutional sites, and we checked Google links until we found one. Then we proceeded to find our HTML file, which we looked for data related with the data set that we already obtained, and entering to government sites and a lot of others, we found a Social Security Administration website, and that's where we obtained our files. And then for last, we found a JSON file, which we downloaded the Food Data Central of the USDA, so it was also a government site, which provided detailed nutritional information on a wide range of food items. For the data cleaning of our data set, we took data given from a URL which points to an Excel file hosted on the USDA website, and using pandas, the function read Excel file into a pandas data frame. The code then identified rows corresponding to processed fruits and vegetables which were filled with missing values, and replaced all of these occurrences with the mean of the column. So for each numeric column, it calculated the column mean and filled it in instead of the missing value. And finally, we used iLog, and with this, we removed the last 3 rows from the data frame, which were non-relevant, and they were just footnotes that are often present in data sets.
For the HTML data cleaning, we took CPI data from the Social Security Administration and analyzed it using Beautiful Soup. Here we just extract the table data, focusing on those rows and columns, and add them in to result in a table where each row is the year and the column is the CPI overall for that year.
For the data cleaning part of our JSON file, we imported very different libraries, and we started by downloading a zip file from a specified URL which contained JSON data, and after this, the code then extracts the JSON file and its data is loaded into a Python object by using json.load, and after this, a list of desired nutrient columns is defined, which includes protein, energy, fiber, sodium, in some others. And the code iterates over each food item in the list and extracts the relevant nutrient information. So for each food item, a pandas data frame is created with the nutrient data indexed by the food's description. And after this, a final data frame is created and loops over each line to see if there are missing values, and if it finds missing values, it will replace it with 0.00 with a float of 0.
For Insight 1, we took our data from the historical CPI Excel sheet from the USDA and categorized our foods based on whether they were unhealthy and healthy. And from there, we took averages across the CPIs from year to year to determine the trends of food prices for healthy foods versus unhealthy foods. What we found doing this analysis is that unhealthy food is slightly more expensive than healthy food, despite the general idea that healthy food tends to be more expensive. and that the price of unhealthy foods will increase and decrease at a much faster rate versus the healthy food prices. And that food prices on average for the past 5 years are increasing, and the current increase is quite rapid.
The Consumer Price Index (CPI) was used to look at and compare the average prices of goods from 1990 to 2000, from 2000 to 2007, and from 2008 to 2022. So that code takes the CPI and splits it into these three time periods. It then finds the average cost for each period and displays it. As we can see, we have how the cost of various things have transformed over time and how the cost of living changes over time as well as the market. Each time period's results are shown as a different data frame, and these results make it easy to see how prices for consumers have changed over time. Now, this data visual shows how the cost of living has changed over this time period, and it shows how prices for customers have changed over time in response to changes and trends in the economy as a whole. So it supports the information that was given by Insight 2, and each of the different lines is for a different time period.
For Insight 3, we wanted to find the average percent increase across the board with using the data from the Social Security Administration. So using that CPI data, wanted to see the average percent increase to give us an idea of inflation over time and how things progress year to year. So in our visualization of the average percent increase for the Consumer Price Index, we found that from 1974 up to the present times, it is down. It tends to trend downwards. However, there are some large spikes that could be attributed to, whatever was going on in the world at the time. But what it seems like the current state is that we are trending downwards.
For Insight 4, this approach involves normalizing the nutrient content of various food items against their calorie count. So we used the JSON data file for detailed nutritional information, and by calculating the amount of each nutrient per calorie, we're able to compare the nutrient density of different foods, regardless of their total calorie content. This method allows for a more nuanced assessment of food items, identifying those that offer more essential nutrients per calorie. It also aids in differentiating between if a food is considered healthy or unhealthy based on their nutrient to calorie ratios, which provide valuable insights for nutritional studies and dietary planning.
For Insight 5, we use the data the JSON file data, which is just a massive compilation of nutrition facts across like about 7,000 food items in like your everyday grocery store. So we performed this correlation analysis between sugars and fats, saturated fat and sodium, and protein and energy, which is calories. And what we found is that energy and protein are positively correlated while the rest are negatively correlated. Now, this doesn't necessarily account for how certain food items may not have certain nutrition facts, but as a general rule, this is a good analysis to see what correlations exist among any given food item. Our final results are that while CPI is trending downwards overall, the cost of food is increasing. We see in visualization 1 that unhealthy foods and healthy foods generally trend together, and that trend is upward at a rapid rate. However, CPI across the entire economy is trending downward, also at quite a fast rate, which means that while inflation overall trends downwards, food inflation is going up, and that means Americans are having to spend more money on food, but not as much on other essential living items. And while we don't really know what could be the culprit of that, it is important to note that that is the current state of things.